Okay, so if you're not here for any of this and you don't watch the video, that's just tough. Understood? Now, I made up the test, and the test is very rigorous. The test is going to be on Sunday, part 1, and on Monday, part 2. Now, Sunday's date is the 10th, right? Sunday's date is the 10th. Can you check that up on for me? It's going to be 10 December.
Yeah, it's 10.
And then this will be 11 December. What I did was I checked with Mr. Enoch, and he agreed to switch with me to flip periods 1 and 2. So you'll have the whole time, and it's not a problem. Understood? Yeah. Okay, so now there's something that I put on the test to complete nomenclature. It's not hard, it's very easy. Okay. Now, you have your periodic table, which is approximately like this. Obviously, it's not the same, but similar. It's a rectangle, essentially, correct? Periodic table. And you'll have a periodic table when you take your test. I'll make sure everybody has a fresh one. With names. No, I can't have names on it, can I? No, you can't have a periodic table. So you're going to have to know all the elements I gave you. The place, the number. You have to know how to number a periodic table, etc. So you're going to have to know the whole ball of wax. I'll give you a blank periodic table. That might help. Understood? Yeah, understood? Is that okay? Okay. If you can use a blank periodic table, you guys are gold. I'm telling you, it is a skill that you will take with you to grade 10 and grade 11. So it's pretty cool. All right, now, let's say that this is your periodic table. This section here are nonmetals, correct? Nonmetals. Now, if you take two nonmetals, remember we talked briefly about bonding, and we'll make sure I speak briefly about bonding. I'm not going to teach you bonding more than you already know. Just give me a second. We identified two types of bonding, ionic and covalent, correct? Sharing was covalent, and transfer of electron is ionic. So go back to your notes, look at the video, and keep it simple. Clear? Now, if I have something, for instance, from the left side of the periodic table, far left to the far right, that's going to be generally ionic bonding. The farther apart they are on the periodic table, generally it becomes more ionic. Clear? Now, this is the weird deal. Okay, remember I said usually the metal, the positive is on the left, the negative is on the right. Well, what we do in chemistry, we kind of fudge things a little bit. Because nonmetals can bond, for instance. That's one that you know very well. We talk about acid rain, SO2. So we know that nonmetals will bond. Nonmetals bond covalently. And they bond molecularly. They're molecular. They're molecules. Remember the individual unit of a compound that is ionic is called the formula unit. Remember that? Okay. The individual units of a compound that bonded covalently is called a molecule. Okay? So molecules are over here. Now, you name them, there's a special class of nomenclature for naming them. It's actually extremely easy. It's not hard. Okay? It goes like this. I'm going to erase this. Okay? It goes like this. I just wanted to include it for closure. So you've had an introduction to nomenclature. Now, there's nomenclature on the test, but it's not like a test that I give you relative to nomenclature. It's a much easier test. Okay, if you were my chemistry students, I would give you a very, very, very large, broad, very large 2-day nomenclature test, but that's not what we're going to do. Okay, it's just going to be a few things. It's not whatever it seems. If it were chemistry class, it would be much bigger. So you have to know prefixes. Excuse me. You have to memorize prefixes. There's only 10. Some of them you know already. What's the Greek prefix for mana? I just told you. For one. What is it? Mana. Okay. I need you to speak up. Okay. What is it for two? What is it? Die? Die, yeah, D-I. You say bye? Yeah, no. Die. How about three? What is it? Try, etc. Understood? How about four? Four is weird. How about four? Tetra. Okay, how about five? Penta. How about six? It's same in math. A six-sided geometric figure is called a hexagon, right? So hexa. How about seven? Liver disease. There's a liver disease. Sounds like a liver disease. A and B. Hepatitis. So hepta. Hepta. Sounds like hepatic, liver, hepatic. Hepatitis, swollen liver. So hepta, not hepta. Hepta is 7. What's 8? Octa, 9. Sounds like what you call your grandmother in Italian. Nona. Nona. And what's deca? Okay, good. So you know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So mono, di, tri, tetra, penta. What's next? What's 6? Hexa. What's 7? Hepta, octa, nona, and deca. Right? Decagon, right? Okay. Now, so how do I apply them? There's two of them. Now, there's only one caveat. I don't know why they have this rule. It's kind of weird. It just makes things a little confusing. How about, let's see. Yeah, those three should be enough to explain. All right, now, this is the only caveat. Obviously, you use them to tell you the number. It has nothing to do with charges. Okay? You just do it for the number. So, this would be what? Dinitrogen monoxide, right? Dinitrogen monoxide, right? Right? Yes or no? What would this one be? Dinitrogen pentoxide, easy? Right? You should be able to get that, right? Okay. What's this? What is it?
Carbon dioxide.
Why didn't you use mono?
Because there's two oxides.
No. Well, this is the weird thing. Here's another one that you should know. Being dyslexic is hard. I spell backwards. I do weird things. You don't use mono if there's one positive side. We still say positive, negative. We still say that. Okay? We still say that. Okay? So you have the positive side and the negative side, right? Yes? Okay. So if there's only one in the positive side, you don't use mono. The only time you don't use a prefix is if there's one positive side. So, what's this? You already said it. Carbon dioxide. What's this? What's this? Carbon monoxide, right? What's this? Nitrogen monoxide, right? Okay, so that's it. What's that? Dinitrogen trioxide. Easy? Not hard, right? So you have to know that. I think that is one of the more user-friendly ways of naming compounds. Wouldn't you agree? Yes? All right, so the test is going to be pretty thorough. Okay, let's see, here's the test in my hands. Okay, show the camera. Okay. We have the French guys here.
Just one small amendment in the routine. You have a first in the fifth period to the fifth period. Instead of fifth, you do the fourth period. Fourth period. I have
Right. I have no idea what he said, but you get the message?
Yes.
Okay. Oh, this is what I heard. I didn't bash. What?
You have to edit the video to 12.
We don't have to edit that out. It's just, life in the classroom. You always get visitors. Okay, so, all right, so you need to be able to identify different groups, okay? You have group 1 through 18, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I don't think that all comes up on the... Does that all come up on the thing? It does, barely. Okay, let me renumber that because I can get it. All right, so what is group 1? Anybody know what that is called? Some of this is chapter 4, some of it is chapter 3, but I'll tell you why. Is that better?
Yeah.
Still kind of going down on the slant, huh? It's better? Okay. So why, you see, it's difficult to teach this as 4 discrete chapters. I'm kind of mixing things up back and forth. Yes, you have the videos where I read the chapter to you and I have additional resources relative to pictures, etc. So those videos are going to be important to look at. And please criticize them. If you don't think they're good, I need to evolve the process. Yes? So if you don't think a picture's good, you tell me. You don't think something's good, you gotta tell me. Understood? Okay, now. So you have to know what is group 1? What is that called? You remember? What's it called? Alkali metals, right? They're called alkali metals.
Yeah.
You get it? And one of the reasons they're alkali metals is they can form alkali substances. For instance, sodium hydroxide. It's a base. You ever hear of lye? You ever hear of lye? Lye is a very, very harsh, corrosive substance. It's like the opposite of an acid. You've heard of an acid, right? Anybody hear of pH?
Yeah.
Okay, so you have pH, right? Right? Where 1 is very acidic, like your stomach acid. 1. Well, 14, this is an acid, this is the base. So that's a very strong acid, pH 1, and that's a very strong base. So that's like a pH of 1. You can really get sodium hydroxide, very basic. Okay? A very strong acid, like the acid in your stomach, would be HCl. It's called muriatic acid, the old name, in the olden days, muriatic acid. HCl. Your stomach produces HCl. The reason your stomach produces HCl, the only thing that's digested in your stomach is protein, not starch. Starch is broken down in the mouth, mixes with salivary alpha amylase, and in the first 20 centimeters of your small intestine, you get the digestion of starch in your duodenum, and you get more amylase mixing. But in your stomach, you get an enzyme called pepsin. Pepsin. And the thing about pepsin by itself won't digest proteins very well. It needs a catalyst. You know what the catalyst is? Acid. The catalyst. And then it works really well. So if you eat dinner and you drink a lot of water during dinner, it doesn't help the digestion. You shouldn't be eating a lot of liquids during dinner. You should certainly have some, but you shouldn't be gulping a lot of liquids because you're going to dilute that acid. And you shouldn't also, don't have a lot of starches. Don't have a lot of starch because they won't digest well. You'll get gas. You get when starches don't break down quickly, you get gas, intestinal gas, and stinky, and you get this putrefaction of the starches, and it's because the starches, you're overwhelmed with starch. You should be eating some protein and some starch, very balanced plate. Okay, but the reason you're producing that acid is because of it catalyzes the pepsin. But this is, anyway, not to get too far off track, that's alkali metals. What's group 2 called? Alkali earth metals. Alkali earth metals. We have another visitor for me. What's this? All right, thank you. All right. So alkali earth metals. Okay. Okay. Where are the halogens? These are alkali earth metals. Okay. So alkali metals. And alkali earth. Yes, that's alkali metals. That's 1, 2. Where are the halogens? Halogens. Where are the halogens? You remember? 7?
17.
Very good, Samia. 17. Tell me what the halogens are. Do you remember? Remember those elements on the periodic table I told you to know? Fluorine, chlorine, bromine, iodine. Yes? Correct? Yes? Where are the nonmetals? This is 17. Where are the nonmetals?
18.
Where are the nonmetals? Nonmetals are kind of in here.
19, 14, 15.
There's like a jagged line that goes down. That's a terrible jagged line. But they're in here. They're in here. They're like 13-ish to 18. Yes? There's that jagged line, kind of goes like this. And it's terrible. It's a terrible representation. But you get the idea, right? These are non-metals. Where are metalloids? Where are metalloids? They have the properties of both metals and non-metals. They're used in semiconductors. They have a lot of applications in industry, especially high tech. They're along this line. They have a little bit of metal, a little bit of non-metal. They have characteristics of both. Yes? Characteristics of both. What's the... So these are metalloids right here. There's really no way of saying. It's essentially 13 to 16, let's say, but it's along that line. Yes, it's along this line. Those are metalloids, either side of the line. So metalloids are both, there are metals that are metalloids, and there are non-metals that are metalloids. Yes, makes sense? Sort of, right? For instance, what is, if you could describe the non-metals in terms of room temperature, what do they look like? They are mainly what? Solids. They're mainly solids. Yes? Carbon, silicon, phosphorus, they're all solids, with the exception of what? Which ones are gases? The top along here, you know, this is a solid, boron, aluminum is a solid. But these here, you have oxygen, nitrogen, yes? You know, fluorine, phosphorus is a solid, but then you get oxygen, nitrogen, fluorine, they're all gases. So your gases are like here. Your gases are along the top and along here. Which one is, really the only liquid at room temperature is what? Is what? This is actually goes to here. Chlorine. Then bromine is what at room temperature? Bromine's a liquid at room temperature. What's iodine at room temperature? Yeah, we talked about that. It's solid, it's crystalline. It will sublime. It will go right into the gaseous phase. It doesn't have a liquid phase, really. When you put iodine on a cut, what are you actually putting on the cut? Iodine? What iodine is used in medicine for an antiseptic. But what are you actually putting on your cut? Are you putting iodine, pure iodine? What are you putting on your cut? You're putting a solution of iodine in water. Maybe something else, maybe another solvent. But it could be in a paste, it could be in a cream, betadine solution. It could be a variety of different solvents that are in there. Yeah. So you're putting a solution containing iodine. All right, what else? Where are the transition? Can I use this to erase? Where are the transition elements? Where are the transition elements? Where? Here? Yeah, right here. From like this. 3 to like 12 in there. Yeah? Transition elements? Yeah. What are the representative? We didn't really talk about this yet. I just want to introduce you to it. What are the representative elements? They don't really say this in the book, but it's very important. Representative elements. Which ones are those? Those are the ones in the first 2 columns and the last 6 columns. They're called representative elements because they have so many applications. They're called representative elements. Groups 1 and 2 and 13 through 18. Yeah? Easy? Okay. Yeah. There's not going to be a chapter 4 test. What I'm doing is I'm combining 2, 3, and a little 4 for this test, and 2, 3, and a little 4 for the next test, with a pinch of 3 thrown in, with a pinch of 1 thrown in for the first test. Okay? So, not much, just a pinch. What chapter is like solutions and reactants and products and things like that? What chapter is that? Some of that's chapter 2, yeah. So you've got to know chapter 2 plus the extra stuff I'm doing. I'm not going to give you 4 separate tests. It's just too weird. Okay? Because you're really doing 2 things. You're doing You're doing the organization of matter, solutions, elements, compounds, right? And you're doing the periodic table. But you're doing it in 4 chapters. So the material is not, it's not discrete. It's very continuous throughout the whole 4 chapters. Understood? So it's a nice way to organize the information, quite honestly. But if this were a chemistry class, I'd give you 2 tests. I'd give you one on the organization of matter and another one on periodic table. I'd give you a separate one on atoms. Like for instance, in the next test we're going to put on there like the development of the periodic table, the scientists involved in it, a little bit about atomic structure on the next test. Yes? Okay. So what else? Where are the inner transition elements? The inner transition elements. We have another visitor. Will you please go see what she wants? Oh, we have a delivery. It's always exciting here in 503. Is that yours? All right. Where are the inner transition elements? I made kind of a table. Maisha, didn't you ask me what those bands at the bottom were for? There were 2 of them. 14 columns, remember? And I took this and I spread it out and I inserted them. Remember? These are the inner transition elements. These are the inner transition elements. What's the heaviest naturally occurring element? I'll give you a hint. It's in the inner transition elements. These are all naturally occurring. The top band are all naturally occurring. Anybody know? What is it? You! Yeah! A D. Well done! Uranium, yeah. What's the atomic number of uranium? You gotta know that.
So one.
Remember, you got it in your mind. We're gonna have some practices. What is it? 130. This isn't the lottery. 92. What was, 92. All right. So, right. What else do we have? We're doing well here. Non-metals. Where are the noble gases? 18. Noble gases are 18. Metalloids, you know. Representative elements, you know. All right, now let's do this. Let's do charges, shall we? Let's do some nomenclature. Oh, also you're going to have to know. Remember from the last test that you did very poorly on? Not all of you. Some of you did. Some of you did very well. So I'm going to give you another shot at it, and it's going to be on. Remember solutions? Let me read you off some of the words. Product, phase, physical change, liquid, mass, element, solid, that kind of stuff. You remember? Yes? You remember that? Remember that stuff? Yes? What's a phase? What's a phase? It's used in solution chemistry. The word phase. A phase is an obvious set of physical boundaries, right? Yeah? Okay. Like this whole room is multi-phase. You're a phase, you're a phase, you're a phase, you're a phase, right? The books are phases. Whereas salt and water, inside the beaker there's only what? One phase, right? A solution has to have how many phases? One phase, yeah? Very good, okay. So let's do some nomenclature. Okay. what did we start off today? We started off with, I call it the Greek prefix system. Did you get the email I sent with those YouTube? Yes. Well, I'm going to tell you something. Okay? I know that you like to communicate with her, but can you do it later? Unless you have no friends and this is like some form of harassment that I can deal with. Is that what this is? Sammy, is he bothering you? Because let me know. Okay? Good. All right. Now, those, I'm going to give you a hint. If you look at those videos, you'll have zero problems with any of the tests. You get hundreds on the test. I'm telling you. Those, I'm not just suggesting those because I want you to waste your time. I'm telling you, if I give you a suggestion, it's pretty good. Who's missing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who?
Nabila and Kamila.
What's the first one?
Nabila.
Tamina and who else?
Nabila.
W. Okay. All right, now. So some books call. Remember we did this carbon dioxide. Some books call it a binary molecular nomenclature. Okay, it's binary, right? Makes sense, right? Remember binary? That's binary, isn't it? Right? Binary. This is, you could say this is binary ionic nomenclature if you want. I don't know. I've never heard that, but whatever. So, let's do some problems. Which one, what's that? What's CO2? Carbon dioxide. What's NaCl? Sodium chloride, right? So, if it's from 1, 2 plus 1, 2, 3 plus what? 18, 17, 16, 15. So you don't need a Roman numeral, right? They only have one. Why do you need a Roman numeral? For instance, why do you need a Roman numeral for that? Why do you need a Roman numeral? Why do you need a Roman numeral? Maisha? I mean, I did this all before. And if you think it's exciting to do this to people who have their head down and just getting deliveries and then leaving class and putting your delivery away or doing weird things or wrapping yourself in a coat because you're too cold, you know, why do you need a Roman numeral? Yeah. Do you think I can hear you? So you're making fun of people who are hard of hearing by whispering. Is that what you're doing? Samia, what do you think? All right, you're making this way too complicated. What is it? What is it? Well, yeah, of course. It's not in these groups, okay. But it has they have more than one oxidation state. They have more than one oxidation state. Copper has two major ones. You get this. Copper 2 oxide and copper 1 oxide. So which one is it? Well, you got to say which one it is. Right? You got to say. Right? These only have one oxidation state. This is +1, +2, +3, -3, -2, -1. Right? Those groups only have one oxidation state. The transition elements, mainly the transition elements, not all of them, but mainly, have multiples. So what we do is this. We say this. If an element is a transition element, we usually write the Roman numeral. Even for things like this. Zinc 2 chloride. Even though zinc is generally only has an oxidation state of 2, that whole row, that row, okay? What row is it? 12? Yeah, 12. Zinc, cadmium, okay? I think mercury's in that row. Anybody have a periodic table somewhere? That row is generally +2. Silver is another one. Silver 1 chloride. It's generally, silver just has generally 1. But because it's a transition element, yeah, zinc, cadmium, mercury, generally +2. But mercury could have +1. It's rare, but I think, don't quote me, I should know that. But because silver is a transition element, we use Roman numerals. Same thing with zinc, yeah. Right, now. So, let me put some on the board. Okay, let's name these. What time is it? All right, I got 1 minute. So what's this? What is that? What is it? Dinitrogen trioxide. Okay, good. What's this? Transition element. What is it? Iron. Iron what? Iron 2. How'd you get 2? Well, this is -2. There's only 2. There's only 1, right? This whole thing is what? -2. Therefore, this whole thing is +2. Correct? How many irons are there? 1. So each one must have a charge of 2. So the answer would be iron 2 oxide. What about this? Nickel chloride, 100% wrong. What are you forgetting? Nickel what? Nickel what? Nickel what? Nickel what? No. You use the prefixes for 2 non-metals. Yeah. Nickel what? You need a Roman numeral. Come on, Aisha. Instead of laughing at his answer, maybe you want to come up with your own. What do you think? What would it be? NiCl 6. What's chlorine's charge? It's in group 17, remember? What's its charge? -1. So this is -1. Therefore, what's the whole charge of the negative component? I can't believe you're this bad. It'd be what? What's 6 times -1? You don't know? Yeah, -6. Nobody's this bad. I've been teaching all over the world. Nobody's this bad. It's called lazy. That's what it's called. Okay. So, what would be the total positive component? +6. Good. How many nickels are there? 1. So what would be the charge of each nickel? 6. So what's the name of the compound? God, it's like pulling teeth. I feel like a dentist. Nickel 6! Golly! Nickel 6! You know, I get people that watch these videos from all over the world, and they leave me comments like, you know, You know, what is this class? Is this like in a hospital? In a brain trauma recovery ward? I mean, are your students like special? I mean, are they intelligent? I mean, how do you say that politely? You know, they don't know. They're completely stunned. You know, I should say the name of the school. Boy, that wouldn't go over really big, would it? Holy mackerel! They do. They leave me all kinds of funny comments. I mean, some of them are not offensive, but I think they're funny. But they're like, you can imagine what the comments are. But they are. I get one comment saying, "Is this like a brain trauma recovery ward at a hospital?" All right. What about this one? And we're going to do these, and then we're going to leave. What's this one? Manganese. Good. Manganese. No. Manganese. No. No, it's not manganese. That's for two non-metals. Again, you're hooking onto the two oxygens. Let's use the prefixes. They're two non-metals. What would this be? Time is not up. Time is up when I say it's up. Manganese. No. -2. How many oxygens do I have? So I have -4.
Negative 4 oxide.
Positive, exactly. Manganese 4 oxide. You get it? Manganese 4. What's this one? Remember, aluminum is 50. No, sorry. Yeah, 13. Sorry, that should be a 13. Sorry. I did the old table. I did the American table. It's 13. So, what is this called?
Wait, -1.
No, aluminum is not a transition. I don't need the Roman numeral. Aluminum is always +3, always, and forever. What's the name of the substance?
Aluminum.
Aluminum bromide. No! You don't use the Roman numerals because it has one oxidation state, period, end of conversation. Aluminum bromide. What's this? It's an acid. What is it? It's nitrate. 8 becomes 8 becomes 8 becomes 8 becomes 8 becomes, that's nitrate. It becomes nitric. Nitric acid. Nitric acid. What's this one? Carbonate. 8 becomes carbonic acid. And we'll end with this bonus problem. Binary hydrochloric. When you name a ternary acid, no prefix, and 8 becomes X, 8 becomes us. Binary acid, hydro, and then ic. They're all ic. Hydro, ic. Understood? All right. Now, I feel like I just taught 5 classes in 40 minutes. I'm exhausted. Okay? Thank you very much, Brain Trauma Recovery Ward. You can go back to your hospital bed and take a nap.